So let's take a look at some different things that can happen with this union thing. All right, so you've got more of a common example would be something like A is equal to, say, 1, 2, 3, 4, 5. Let's make that a prettier 5. 5. And then B is equal to, say, I don't know, like 3, come on, 3, 4, 5, 6, 7, 8, or whatever. And it'll say, what is A union with B? Okay? So now we remember that union is the guy throwing up his hands. He's like, I don't really care where we eat as long as I get some food. He wants everybody, as long as somebody's happy, he's happy. So A union B is going to be all of A, which is 1, 2, 3, 4, 5, and then all of B. Now 3, 4, and 5 are already there, so all I have to do is add 6, 7, and 8. So A union B is 1 through 8. Okay? Now, we can do some things like this, well, really forever, but it's more likely that you're going to see something like this, where it would say 3, I'll try this again, say x is, say, greater than or equal to 5, union with x is, I don't know, less than or equal to -2, something like that. So it could say union, it could also say or. Basically, we're just doing something with it, just trying to make it do something different. So we'll have something along those lines. And the best way to do this is to just set up a what's it called? A number line. So we can have something like this. Let's say -2, 0, and 5. And I just like to get things lined up. X is less than or equal to -2. I'll do it again. X is less than or equal to -2. Or less than. We'll just change it to less than to make it interesting. So for x is greater than or equal to 5, we'll say x is greater than or equal to 5 and go to the right. Now some books are doing this now. They'll have a bracket and go off to the right, so it just depends on which book you're using. And then on the bottom, so it's x is less than -2, so it's going to be an open circle and going off to the left. Or similarly, it could be a parenthesis and going off to the left. Okay. Now, a good exercise is to go ahead and take this. I kind of made it too big. Now I can't shrink it. Ah! So I guess I'll just do it like this. So if I want to write this in interval notation, the first one, going from left to right, if you'll remember, I would write that as 5, bracket to infinity, parenthesis. The second one I would write as -infinity to 2, or to -2. Again, not inclusive of the endpoint. But now if I want to say x is greater than or equal to 5, or x is less than -2, now what I want to do is I want to go through and I want to see not what these guys have in common, but rather I want to see what do I need to do as a minimum to keep this guy happy. Ah, was not intentional. So sometimes it helps to take like a line and think about moving from left to right. So as I go from left to right, I can see that the second one is filled in, filled in, filled in, and then it's open. So that means I want to go filled in, filled in, filled in, filled in, and then open. Then as I'm going along, so that's all covered, that's all covered. Then as I'm going along here, though, neither of them has anything. Neither of them has anything. Neither of them has anything. And again, I'm looking at the top two. Neither of them have anything. And then I get over here. Now when I get to the 5, the top one's filled in, and it goes out to the right forever. So that means down here, the 5 is going to be filled in, and it's going to go to the right forever. Like that. Okay? So another way to think about it is to literally take this thing here, put it down here. I'm not going to do it because it'll really mess up my drawing. And then to take this guy and move him down here. And then wherever they overlap, or not overlap, but just anywhere that they happen to be is part of your solution set. So your interval notation here, again reading from left to right, will be -infinity to -2. And then that's going to be union with bracket 5 to infinity. Got it? Kind of? See where we're going with this? Alright, so let's try something else kind of similar. Let's try 5x, say minus 3, I don't know, is less than or equal to 12. And let's say x plus 1 is greater than or equal to 5. I'll say or, not and. And x plus 1 is greater than or equal to 5. So take a minute and pause the video and actually go try to work this out. See if you can get a good solution for this thing. See if you can get something going. And if so, great, come and check your answer. And if not, you know, take a minute and see, come back and see what maybe you missed. So pretending you did that, whenever you're solving these, you want to solve each of them for x first. So I'll have to add 3 to both sides and get, let's see, less than or equal to 15. Divide both sides by 5. So x is less than or equal to 3. Or subtract 1 from both sides. X is greater than or equal to 4. So I'm going to draw these out. Too much. And it's just good practice, I guess, to actually go in here and write them out in interval notation. So less than or equal to 3, so it's a hole on the, oh, not a hole, but a solid on the 3 and off to the left. A solid on the 4 and off to the right. This greater than or equal to 4. And just to remind you what interval notation is, going from left to right, negative infinity to 3 inclusive, and then 4 to infinity non-inclusive. Let's see. So now if we want to say x is less than or equal to 3, or x is greater than or equal to 4, what I want to do is I want to fill in any place where either one of them is filled in. So the top one's filled in from here all the way to 3. Nobody's filled in from 3 to 4, but then the second one is filled in from 4 and then goes off to the right. So that means that my solution is negative infinity to 3 union with 4 to infinity. Like that. Funsies? Okay. Now, just like you can have someone that's so picky there's no possible way to keep him happy, you can also have someone that's so complacent and content with whatever you're going to offer that they're just happy you're there. So you can actually get an interesting solution with these union problems. So say that x had to be greater than 6, or let's say greater than negative 6, or x has to be less than or equal to 10. And either one works for our person. Either this or this. So I'll draw this out. Negative 6. I just like to mark 0 because I'm a nerd. It's fun. So x is greater than negative 6. So greater than negative 6, but not inclusive, and off to the right. X is less than or equal to 10. So fill in on the 10 and go off to the left. All right. Now this is really interesting, actually. I'll fill this in, negative 6 to 10, no wait, to infinity, and then negative infinity to 10. If you look at what happens here as I go from left to right, there is no place that's not filled in by somebody. So if I say that x is greater than negative 6 or x is less than or equal to 10, as I go left to right, I see, okay, the second guy has this arrow filled in. Now as I get to negative 6, he includes negative 6. He doesn't. He doesn't include negative 6, but he does. So I still have to include negative 6. And then I keep going, and then I keep going, and then I keep going. He includes 10, and he includes 10. So again, I keep going, and then he includes this right arrow. So I have to include the right arrow. And so now you look and you see, well, what on this number line have I shaded in? And the answer is everything. I've gone from negative infinity all the way to positive infinity. So really, my answer here is all real numbers. Okay. So again, you can have somebody that's so picky you can't satisfy them, or you can have someone that's just so happy to be there, anything you give them is going to be fine. About the only other weird thing that can particularly happen with these is, say you had something complicated and you reduced it down to this, like that. Okay, so this one might look a little weird. I don't know what the deal is with 10 and 6 right now. They're just my favorite numbers. So 0, 6, and 10. 0, 6, and 10. So the first guy, go ahead and actually, let me say this, go ahead and try to work this out on your own, expecting to get something a little weird, and then come back and see if you figure out how to deal with it. Okay? So again, assuming that you did that. So x is less than or equal to 10, or x is less than 6. So if I want to say, where is x less than or equal to 10, or x is less than 6? And the answer is, well, working from the left, this arrow's filled in. Left, 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 left. Now this guy has an open circle on 6, but he's filled in 6, so I can keep filling in 6. And then I keep going, and then I keep going, and he's filled into 10. And then we're open on the right. So since we're open on the right here, that means we're open on the right here. So really what's happened is that in our final answer for this one, we found actually that the second condition was completely irrelevant. Our solution really says from negative infinity to positive 10, or that x is less than or equal to 10. So it's kind of interesting that, you know, you basically, so this guy was sufficient and this guy was irrelevant. Because the fact it was an or statement, we were already including all of him anyway, so it wasn't even necessary to make that specification. You know, it's like, I have to have spaghetti, and I want to eat Italian food. Well, it's like, well, that would be an or statement. You know, if you have one, you're going to have the other. So it's just kind of silly. As long as we've taken care of it, then we're good. So this is another thing that you want to look out for whenever you're looking at union problems.